Assalamualaikum warahmatullahi wabarakatuh. Hello everyone. My name is Muhammad Hayo Dimas Dewantoro. In for today, I will present my industrial instrumentation project. So let's start. So for the topic of the project is crude oil processing. It has three parts. First, we have the process flow diagram or PFD. Second is the control block diagram, and third is the PLC diagram. First, I'll tell you what is a process flow diagram. A process flow diagram, or PFD, is a visual representation of the steps and equipment involved in a particular process. It illustrates the relationships between major components at an industrial plant. It provides a systematic overview of how inputs are transformed into outputs through a series of interconnected unit operations. So here's the PFD of the crude oil processing. The explanations will come shortly. Okay, so it has some components here. First, we have the centrifugal pump. So the crude oil goes to the centrifugal pump, and then the pump provides the necessary pressure to push the crude oil through the subsequent process units. After that, there's the cold preheat train. So the incoming crude oil is heated using hot streams from downstream units or by utilizing waste heat from the process. And then we have the wash water pump. It's activated in parallel with cold preheat train, and then the water pump distributes wash water to the process to assist the separation of impurities and water from crude oil. And then we have emulsifying device. After the preheated oil and wash water are mixed, it will go to the emulsifying device. It helps break down any water in oil emulsions present in the crude oil, facilitating separation steps. And then we have the shell and tube heat exchanger. So the crude oil flows through the tubes while a hot utility, for example steam, circulates in the shell. The heat exchanger helps achieve the desired temperature for subsequent process steps. And then we have the desalter. So an electrostatic field is applied to the crude oil to break the water in oil emulsion. So the separation of water, salts, and impurities from this crude oil is facilitated by the electrical charges induced by the desalter. After water, salts, and impurities are removed, the desalted crude oil goes to the next process. And then we have mud pump. It helps maintain pressure and flow rate during the process. And then we have the hot preheat train. So the desalted crude oil entered the hot preheat train. So the hot preheat train is same as the cold preheat train. So heated using hot steams from downstream units or by utilizing waste heat from the process. So after being preheated by the preheat train, the oil will go to the crude furnace and typically continues with additional crude oil refining steps such as desalting, conversion, and so on. Okay, here we have the control block diagram of the crude oil processing. So first we have the input. So the input elements are the crude oil temperature and density. And then it will go to the controller. So it has the preheat train that controls the temperature, and then wash water mix, emulsifying device, desalter, and mud pump controls the density. And then it will go to the plant. And then for the feedback elements, it will go to the shell and tube heat, and then it will go to the brine exchanger. And then the system will also give wash water as feedback to the crude oil. And then the output will be desalted oil, and then that desalted oil is preheated in hot preheat train and goes into crude furnace with new temperature and density. And then here we have the PLC diagram of the crude oil process. It has 8 rungs. The first rung is a latching system to turn on or off the crude oil process. The relay pump on will activate the wash water pump. And then the second rung is to activate the cold preheat train after activating the wash water pump. The third rung is to flow the wash water. And then the fourth rung is to activate desalter with conditions of the cold preheat temperature is in the desired value. the preheat oil mixed with wash water, an emulsifying device finishing breaking down the water in oil emulsions. After of those three conditions are met, the desalter will turn on. After desalter is activated in the fifth rung, the mud pump and shell heat tube are activated. And then in the sixth rung, when the shell heat tube and wash water pump are activated, they will activate the brine exchanger. For the seventh rung, when the desalter and brine exchanger finish their task, the desalted oil will go to the hot preheat train. And then in the eighth rung, if the oil in hot preheat train reaches the desired temperature, it will go to the crude furnace. So here are the links for the reference and the PLC diagram. And that is all from my project. I'm sorry if there are any mistakes in this presentation, so thank you very much.